Well,
Okay.
yeah. So,
Okay.
cool. I will give a brief intro at the beginning. So hi guys, this is Chris from DoraHacks. Welcome to the very first ETH Research Grant and DoraHacks project demo sessions. So ETH Research Grant is dedicated to funding projects and research topics in the Ethereum community and promoting the further development of Ethereum. Ethereum Research Grant will be the first practice of Plonk-based MACI, requiring only one single trusted setup in ZK proof. In the future of MACI runs on DoraHacks, Plonk-based MACI will replace its Gross 16 scheme before. The MACI voting round is live on DoraHacks website already. Just for all the audience in front of the screen. Yeah, so that's the background. So far, we have already received a little bit more than 30 plus product submissions. For the first batch, we are very happy to have 5 top teams from those participants to join us to today's project demo sessions. And they are SoulWallet, ETH Storage, Eigen Network, Eigen Network, ERC 1155 Delta, and ZKSAFE Password. So yeah, without further ado, let's welcome the first team, which is the SoulWallet, to start. And before we start, please keep in mind that every team will have no more than 12 minutes for presentation and Q&A. So don't make it too long and complicated. And also for all the audience, if you have any questions during the sessions, please feel free to ask in our YouTube or Binance Live chat room. We will ask those questions for you guys. So yeah, cool. SoulWallet team, feel free to start when you're ready.
Yeah. So I can begin the slide.
Sounds good.
Okay. So can you see this slide?
Yeah, we can see it.
Okay. We can take a quick view of this slide. Introduce the topic is account abstraction and the implementation, ERC 4337. Yeah. So, Ethereum need improvement of account abstraction. And so Vitalik and with the infinitum groups, which is the name of ERC 437 team. Yeah, they build the ERC 437 and it just based on the conception of account abstraction. Yeah, so a quick view. So what's account and what's abstraction? Account in the blockchain in Bitcoin and Ethereum is have many problem and questions. So we just abstract the conception and split into the whole procedure of the traditional ECDSA, you name the traditional crypto signature method, and into creation, activation, interaction, recovery, and management. It is split into 5 parts for different conception. And the ERC-437 gave a practice method with smart contract and the some node factions to make practice in account abstraction. And the main part is about key management and access control, about gas payment. Yes, we know all the pay gas fee with ERC20. Yeah. And you can find some use cases in many scenarios. For example, the famous social recovery or deadman switch. Yeah. You can sign a contract, and if you never use your contract or wallet account with 1 year, or 10 years, I don't know, you can send. And then all the assets of your wallet account will switch to your son, your parents, yeah. So about the signature abstraction, has the power of anti-quantum, I do not exactly conception. Someone has more powerful computing and quantum relation to compute the signature of you. Yeah, you can select the algorithm of your crypto. Yeah, it's a signature abstraction. And also you can set multi-roles like your son, your parent, your brother, yeah, have different control levels. For example, your son will with not over 1,000 US dollars. Yeah. Now we have talk about the gas abstraction. Yeah. So we have many use cases, and the first 7 must make a stand about the MEM Pro to make all the user operations to be built into blocks and on-chain. It's a method and it's also a standard in AA account abstraction. And we are a team of SoulWallet. We build from based on the 4.7 and have some new developments. You can see this triangle, and we'll keep a balance between the security, the cost, the convenience, and find the best way, the best practice to build a wallet to keeping your crypto camera account. Yeah. So it's an overview of all the procedures of the some account verify users and the paymaster and the bundler and the entry point. Yeah, everybody will know this scenario, and we can find some features and mass adoption. For example, we will no seed, no seed phrase, no mnemonic, and no gas. No gas, not kills, no pay, but we can pay the gas with ETH for ETH20, or we pay no gas because the sponsor mode will pay the gas for you. Yeah, like the game, they need many users and they pay the gas for the users. Yeah, and we have the management scenario. If you are enterprise in on blockchain, you have many complex scenario to manage the whole total procedure. So we can provide this management, and we have the recovery or replace ability to make your account never be lost. And also we have programming. The smart contract can be programming. Yeah, it's a total of the introduction. And we have second to introduce the product roadmap. Yeah, now the SoulWallet team is built on a basic decentralized version. Yeah, we have some features. Anyone can create his own crypto account with permissionless. Yeah, just download the plugin and disconnect the internet and create. Anyone can pay the gas fee with his ERC 27, 20 tokens, and pay layer 2 or layer 1 and any VM chain with ERC20. It creates paymaster support. Yeah, it's infra. And anyone can create his recover his account if he loses his private key with his anonymous guardians. The guardian is your social relation. You're never lost. So your social relation with guardians will recover recover your account. Yeah, and anyone can use SoulWallet to interact with any dApps. Yeah, it's the first version. And the second version or second milestone is more trustless. Yeah, we will provide multi-signature account backup. You can switch from one PC to another or just backup all your data you have. Yeah, and we will provide some convenience with Web2 connecting or bindings. For example, the Google account and the Discord login and anything in Web2 can binding with your private key in the Web3. Yeah, and the more features I don't know so much. Yeah, usable or adaptable in future. I will come to anyone to provide some advice to make the SoulWallet be more good for normal people. Yeah, that's all in my slide and introduction. So if you have any questions, and you can ask me or type in. Yeah. So I turn over to the holders. Yeah.
Yeah, sounds good. Sounds good. Thank you very much for the introductions. Yes, one questions will be that like what is the difference between SoulWallet and other smart contract wallet based on the EIP 4337, for example, Argent or like UniPass. So like basically, why do you think that in the future users will prefer to use SoulWallet rather than other projects that are building similar products?
Yeah. So personally, I think, for example, UniPass is build a contract wallet before us. Yeah, it has many abilities, scenarios, and have some power in MPC or SSV. Yeah, so I think they are focused on different area. They want to build DID, and the wallet account is just building around their focus DID. Maybe, yeah. So, for example, the Argent, they are just do not very care the decentralized. For example, the recovery is just binding with the email, and the server is centralized. And the SoulWallet is come from the Vitalik idea and the infinitum teams support. So you can see what I share in the project milestone. The first is we build a decentralized, permissionless. Everybody who can enter the Web3 with a Web3 account, permissionless. Yeah, we focus this idea more. We think this is more valuable, and we have some detail feature different. For example, we keep the guardians private. Yeah, if you be somebody guarding your wallet, your address, your information will show on chain. But we have technical solutions to resolve this question. It's just a detail difference. Yeah.
Got it. Yeah, cool. That makes sense. Thank you very much. Thank you for, and also thank you for the presentations. Yeah.
Okay, I stop the screen. Yeah.
Yeah, that'd be great. Thank you. Cool. So let's welcome the second teams to start, which is the EthStorage. And yeah, Chang, feel free to start when you're ready. Don't forget to unmute yourself. Chang, yeah, you are muted. Yeah.
Yeah. Can you hear me?
Yeah, I can hear you, and we can see your screen.
Okay, so I can start. Hello, everybody. My name is Qiang, and I'm from the ETH storage team. So today I will introduce EthStorage, which is arming to scale EthStorage, Ethereum storage, and pave the way to the future Web3. So what is the current status of the decentralized web? We have the decentralized access protocol like IPFS, and we also have a mature P2P network layer in which we can retrieve the data. Also, we have the incentivized storage layer that help to keep the data persistent. However, there are great limitations of the current decentralized storage solutions. First, those storage solutions have a great limit on the semantics. They only work for static files, which means it is very inefficient to update and delete those existing files. Even just a single byte change. And further, there's no way to compose those data in a decentralized way. So sometimes we have to rely on a centralized server. Second is that those projects have their own ecosystems, which means the user have to use a new wallet address token to upload and store those files onto their systems. So with these problems, we are projecting what features we need in the future Web3. So first, we need rich storage semantics in the decentralized storage, which can support creating, updating, and deleting blobs from a very large amount of data, potentially petabytes. Further, it can be programmable by smart contracts so that the stored data can be easily composed by smart contract code. Second is that we want to simplify the user onboarding experience, which means user can just use the Ethereum wallet to pay Ether and upload and store a large amount of data on top of the Ethereum network. And lastly, we need to have the new access protocol that is able to render those dynamic data from the front end to blockchain and to the storage without any centralized identity. So what is the solutions? Thanks to the development in Ethereum technologies, we believe that we are now in a position where we can achieve those goals soon. First of all, we have data availability thanks to downsharding, which greatly increased the data upload speed using advanced cryptographic primitives. And second, we are able to build external data retention L2 network so that we only store corresponding metadata on Ethereum and be able to store large amount of data in the layer 2 network. And we just need to periodically submit the proof of storage into the Ethereum mainnet so everyone can check the latest data is kept in the network with high replication. Lastly, we also developed our Web3 access protocol, which is able to decentralize access to those web objects hosted by smart contracts. This is the Web3 protocol, which is defined by ERC 4804. It is a way to render web objects hosted by the smart contract. It is very similar to HTTP, so that it can inherit all the good benefits of HTTP. While we are able to identify a resource hosted by the smart contract. And further, access the underlying storage layer that we built. And the EthStorage is a layer 2 solution that aims to scale Ethereum storage rather than the computation. So this is a comparison of EthStorage, which is storage L2, versus other computation L2s. This is another comparison of what Ethereum EthStorage can do versus Falcon, Arwave, and default storage of Ethereum. So with this infrastructure, we believe that we are able to enable a lot of new applications. For example, trusted website hosting and dynamic NFT, which we can change the presentation of images dynamically, and we are able to build decentralized network, such as decentralized Twitter, Medium, or even decentralized Dropbox. So here I will give a very short demo. Let me see. Okay. Why it cannot play? Okay.
This is my Firefox browser that supports Web3 URL. So now type Web3 URL, ETH that we register at ENS that points to the smart contract that hosts our front end. So all the images, HTML, CSS, JavaScript now hosted by the smart contract and returned by this Web3 access protocol. So there are also a couple of interesting examples. For example, decentralized Dropbox. So this is also a homepage that returned by a smart contract, another smart contract, and I can see them all the list, all the previous files have been uploaded before. And in order to upload a new file, what I should do is just drag the file, and then it will ask me to sign a transaction via MetaMask. So doing the whole procedure, you don't need to require any additional tool such as CLI. And once the transaction is confirmed by the network, I can access the file also via Web3 access protocol. So now file has been uploaded, so we are able to access. So it's still a gateway, but we can still use the Web3 access protocol, and the corresponding file list is also updated accordingly thanks to smart contract. So this is an example for decentralized Dropbox. There are also a couple of other examples like Web3 decentralized block, dynamic NFT, etc. So welcome to play.
Okay. So there are a lot of more details of the technology we are building. So you can check it out on the EthStorage.io and Web3UL.io. So yeah, I'm happy to answer any questions here.
Yeah, thank you very much for the presentation. I just have one question for you. So I have seen that you have already mentioned, like, compared to the computation layer 2s or the storage solutions, what is the advantage of EthStorage? But I will also say that it's definitely great. Great to see so many innovations is happening. But I'll also say that all of the great things will require some time and some difficulties to happen. So what is the biggest challenge you see for ETH storage right now to achieve at this moment, I would say? Yeah.
So the biggest challenge is that now we are building the whole EthStorage on the Ethereum mainnet, and users need to submit the storage of proof of storage onto the smart contract. During the whole procedure, user need to cost a lot of gas to submit and prove their storage. So we are exploring a lot to using the ZK technologies to reduce the gas cost. So yeah, that's the biggest challenge that I think.
Got it. Yeah. Sounds like you guys are also exploring something in ZK era. So that sounds definitely exciting. Very looking forward to see how it goes in the new year. Yeah. Thank you.
Yeah.
Thank you very much.
Thank you.
Yeah.
Okay. Thank you.
Cool. So let's jump to the third project today, which is the Eigen Network. So Derek, feel free to start.
Yeah. Hi, host. Can you see my screen?
Yeah, we can see your screen.
Yeah. Thanks. Many thanks to DoraHacker for giving us the opportunity to introduce my project. I'm Zelig, the co-founder of Eigen Network. Today, I will briefly introduce our project. We are Eigen Network, where smart contract becomes private. Eigen Network aims to build a privacy-focused CQM and be highly compatible with Solidity to deliver privacy and developing experience for the developer in the ecosystem. And we all know that blockchain is a pseudo-anonymous platform. The open and transparent nature of the blockchain allows anyone to view the user's transaction transfer records and on-chain activity records. Sensitive information of the user may be easily obtained, and the user is faced with the dilemma of running naked in the Web3 world. So when we talk about privacy of Web3, we are basically talking about the linkability between personally identifiable information and account, the confidentiality of transaction. And Eric Hughes said in Cypherpunk manifesto, privacy is the power to selectively reveal oneself to the world. Users' on-chain behavior should be hidden or selectively closed. And there is another aspect of privacy of smart contract, like risk control rules, portfolio rebalancing strategies, resistant to MUA attack. We want to build a privacy layer that supports private ERC20, private ERC 721, and private smart contract based on the settlement layer and the asset layer. And the developers can design exchange letting the apps on the protocol layer. And we can see many Web3 applications that urgently need privacy protection, such as DID or KYC. We can connect Web3 by selectively close with zero knowledge proof. We can prove to the others that my age is over 18 or my asset exceed 10 millions without disclosing the specific values. And private on-chain asset management keep assets non-custodial and preserve the risk control rules or market making strategy private. Users can enjoy low gas cost, confidential transactions, privacy computation for raw engine, and simple machine learning. Eigen Network aims to facilitate an optional programmable privacy layer by CQM. We have 4 features: scalability, leverage a layered proof system with FRI and KZG to achieve faster proof generation, consistent proof size, and low on-chain verification cost, and general privacy preserving computation, real ZK, built-in privacy primitives like SHA-256, ECDSA, and VRF. And we take developer experience very seriously. We have highly EVM equivalence, auto translation from Solidity smart contract to our assembling for risk meditation. and same security, but much lower gas costs than the layer 1, and more developer experience friendly compared to creating a new layer 1. And we know that privacy was not considered at the beginning of the blockchain design. In the later stage, many blockchains like Monero that focused on privacy functions has been derived, and the user experience of these blockchains is not very good. So we pay great attention to the combination of utility and privacy. And we made good trade-off. We support Poseidon, EDDSA, ECDSA, AES, and adopted an account model extended UTXO with the state. At the same time, we also support solidity and have good composability. Next is our layered proof system. We support multiple layer 1 with Solidity and or Rust verifier. Our layered proof system has no trusted setup for user end and consistent proof size. And we have aggregation proof via KZG layer and recursive proof via FIR layer. And we know that many projects are currently exploring the hardware acceleration of zero knowledge proof, and we are currently conducting the related research. And the VM layer is state machine-based VM by Pale. We have added our private computing capability based on the Polygon Hermits open source implementation, and we support standard template library. And for our performance, the current consistent proof size is 1.1 kilobytes, and the proving cost is less than 20 minutes. But we still have a lot to optimize right now, so we look forward into shrinking the proof size even further. And for our product forms, we have two product forms. One is Eigen Proving Oracle. Users can generate a Stark proof through Stark.js or MetaMask and then submit it to our proof service. We will aggregate the proof to reduce the size and generate one proof. After the proof is generated, the user can submit it to the chain and verify it through Eigen Verifier. The other is our rollup network. On layer 2, user can submit a transaction through Web3.js or MetaMask, and the nodes on layer 2 will process these transactions and generate proofs while interacting with layer 1 through the rollup contracts. Nodes on layer 2 reaches consensus through the chain BFT consensus mechanism, and users can deposit or withdraw assets between layer 2 and layer 1 through the roll-up contracts. So basically, Proving Oracle solves layer 1 their privacy computing needs. Roll-up provides layer 2 privacy computing and can seamlessly connect with layer 1. And the following is our go-to-market strategy. We have many partners in different fields. We recently officially announced the cooperation with ZKPass, and we also have established a solid partnership with Twindowns, For Real Labs, and DB3. We will explore more cooperation opportunities in private payments, ZK KYC, ZK sortation, ZK voting. And for our team, Eigen Labs focus to building efficient zero knowledge proof and privacy preserving system. We believe in privacy is our basic human right, and we are dedicated to apply privacy technology to real world activities. And we have 8 members from Australia and China, graduated from Peking, Tsinghua, and Beihang University, and 3 PhD in cryptography. All of our members previously worked for giant internet company and research labs. We have rich experience in cryptography, blockchain, and privacy preserving technology. And as for our roadmap, we have completed the development of the proof system, and we are designing the VM. So that's all. Thank you. And here are some of our official links. Please contact us if you are interested. And by the way, DoraHacks ETH Research Grant voting activity is on the way, and everyone is welcome to vote for Eigen Network. Thank you.
Yeah, that's awesome. Thank you very much for the introduction. I definitely like the whole ideas. Actually, I just voted for you guys as well. I guess would love to know a bit more like the New Year planning for Eigen Networks. Like what is the next big move for you guys?
Oh yes. Currently, as I said before, we have completed layered proof system, and we are designing the VM. We are currently on the stage of Eigen Network testnet, and I believe in Q1, I think we will launch our mainnet, and in the following time we will design in the ZKSAFE to ensure the privacy preserving functions. And no particular plan for a long time, but we are currently on our testnet, and we are planning to launch our mainnet. Yeah.
Got it. Cool. Thanks for the updates.
Thanks, host.
Yeah. So cool. So let's jump to the next project today, which is the EIP 1155. Oh, it's sorry, it's ZKSAFE. Sorry. So yeah, George and Dan, you can start.
Oh, hi, Chris. Nice meeting you again. Like we met last year by the name of ZK Payroll.
Yeah.
If you remember that. Yeah. So I will turn off the camera to save bandwidth. The internet is quite unstable here. Yep. So let's start. Sorry. Yeah, we are ZKSAFE. We are the security companion for your crypto wallet. I think now we understand the problem with private keys, because we heard a lot of story last year about like people somehow losing millions of dollars from their account, like they all using private key. So now we all understand that like people can lose their private key and private key can be stolen. It's not. And so we are trying to taking like on the market now, people have multi-sign and sort of MPG. So we splitting the private key into different parts and have multiple private keys to do the multi-sign. And they are quite technical. For a normal regular users, it's a kind of a huge barrier. So what we're trying to design is a solution that's suitable for Web2 users and even somebody is new to the internet. So we come out with a sort of a password-based solution, and we just recently submit our EIP. So the idea is that you can basically one of the problem with private key is that the private key cannot be changed. Once the private key is compromised, it will be compromised forever. Somebody else will own your private key like forever. So what we trying to what we think of is that we're trying to create a key that's changeable. You can update and change the key as frequent as you need it. So in this way that if you got any feeling that your private your secret is compromised, and you can just change it or update it. So what we want to do is that we want to introduce this concept with a contract, so with an interface, and let other contract to implement to use it. So that's the motivation behind our EIP. So because a DeFi app, it can utilize this elasticity signature with the transfer fund process. So it will require the user to enter their password, their secrets, and to complete a transaction. For example, to transfer like $5,000 into other account, or even like 10 ETH. So you can set a limit for that, and if it reach that limit, you will require to enter a password, your secret, your password for that matter. So and it's like sort of we try to design this to be an add-on. It's like you have your private key, and then we want to create a option for the user to require a password for a certain transaction to happen. And we proposed this EIP, and was a very simple interface that you can first. Yes, let's explain the technology behind it. So we underneath it, we use ZK technology. We have a secret that's known to the contract on chain, and also it's known to our proof generator. The proof and the user would we input the password, and then along with the transaction data and in the browser, and it would generate a proof, and which gets submitted into our like contract. Like the contract will do the verifying to verify that the transaction data is signed by the secret password by the user, and it's only known to the user. And the user, once the contract confirms that, it will return to the defined app. The defined app can authorize the transaction to make the transaction happen. So that's our simple rationale behind it. So the password will be only known to the user, and even on the contract, the password is not known by the technology of zero knowledge. So the zero knowledge contract on the chain will only save a password hash, and the password hash that's the password hash is the only thing that's stored on the contract, and it's known to everybody. But and the user can generate proof alongside with and sign the transaction data and submit to the contract. The contract can start verifying the proof. So that's that's the whole process. So the user wants to restore some tokens was like certain amount, and then it would after entering the password, the ZK proof generator in your browser would generate a proof, and with along with a signing hash, and the signing hash is called O hash. The O hash and all this data will accept the password will be like the proof, and O hash will submit to the third party contract like the DeFi app. The DeFi app will use this hash information and to talk to our like elastic signature contract, the verifier will verify the proof, and to prove the computation is done right. So the computation has to know the original secret password, and in order to generate the proof, and the proof can verify that, and also verify the signed data, the O hash, to be correct. So once everything is correct, our elastic signature contract will return true to the third party contract. The third party contract can they again go proceed with their transaction. Yes, and that's pretty much our idea behind it. And for the security consideration, our app is quite big because our password hash is stored on the chain. We want to ensure that so that's the only thing that user can iterate through that. But what we found out is that after 12 characters, 12 char, it's 12 numbers and English characters that would take like millions of years to hack that on a RTX 3090s. So and also our password is changeable and can be updated. So if you want to be secure, I think changing is a good way to start. And it's the concept itself is very familiar with our like Web2 experience when you have to enter a password to log in your email account. So I will do a demo with our servers to transfer some funds. So that's our sorry. All right. Let's do this. So I'm currently connecting my account. I will gonna set my password, and I can enter my password to be one. Yep, to pick up my random password. And then I will repeat my password. Sorry, the internet is a bit strange here. So I will set the password. It will take a while. So basically, all our goal is to enable the Web2 user for easy onboarding to Web3 world, where they can, enter the password and log into a certain service, or, when the user have a large amount of like important transaction involve large amount of money, they can have an extra layer of security to ensure that things never get like things they don't lose their money unexpectedly, and also they can they can always feel safe again, because even though they lose their private key, they can still update and change their password to make sure that they will regain their security again. Yep, I think the transaction is completed, and then I officially have a password of my own on the internet, that for the traditional database approach, where the password is storing on a somebody else servers, which is unknown to anybody, and like the administrator of their database, they can update or change your password anytime. But this one is published on Ethereum, like on Polygon chain, and it's on-chain password, and that belongs to me, and nobody can like change it. And it's the first time you actually own your password. I think that would be my demonstration. Thank you.
Great. Yeah, great. Thank you very much, Dan, for the demo and presentations. Looks very exciting. I guess questions will be, what is the business model for ZKSAFE? Hello, can you hear me?
Yeah, the internet is sorry. Yep, I can.
Oh yeah.
I can.
Cool. Yeah. So my question is like, what is the business model for ZKSAFE?
Well, we
business?
don't really know. We are searching the solution, and we don't know the business model actually.
Got it.
Maybe we will have the business model in the future.
Cool. Yeah. Cool. No worries. Thank you. Thank you very much, George and Dan.
Thank you.
Awesome. So yeah, let's welcome the last but not the least teams for today, which is the ERC 1155 Delta. Also another old friends. So yeah, feel free to start.
Hey, yeah, am I sharing screen now?
Yeah.
Awesome. Yeah, it's good to be here again. So hi everyone. I'm Zero X Dario, and I'm the CTO and co-founder of Cetor Lab, and just been very honored to be here to talk about our like a new open source project, ERC 1155 Delta, and yeah. So, oops. Yeah, so what is the ERC 1155 Delta? And so it is a generic use batch mint NFT smart contract. So it is just like the well-known ERC 721A from Team Azuki. And ERC 1155 Delta is highly optimized and provides more gas saving than any existing solutions. And apart from that, it uses much less storage and thus it has less impact on the blockchain resource, and which is good for the node operators. And even though ERC 1155 Delta use ERC 1155 as its interface, but each ERC 1155 Delta token is unique, just like any ERC 721 tokens. And just before getting to more details about the ERC 1155 Delta, I'll just first talk about like the 3 criteria we identified for an ideal solution for the scalable NFT smart contracts. So first is that we want to have a constant gas usage in batch minting. Namely, the gas usage is essentially the same no matter the number of tokens you are minting in a single transaction. And ERC 721A is the first implementation that achieved this. And the second one is the gas usage should be independent of the token ID you want to transfer. And this is an issue for ERC 721A and ERC 721 SAI, which is one of our previous works. It improves the by using a fast indexing algorithm to solve this issue. However, both ERC 721A and ERC 721 SAI don't provide gas refund while burning the tokens. The information of the tokens are not released and remain on the chain after they are burned. This is because the gas saving mechanism prevents them from doing so. On the other hand, Open Zeppelin's ERC 721 implementation has gas refund, but it scales poorly in batch minting. So unlike ERC 721A and ERC 721 SAI, ERC 1155 Delta uses a completely different mechanism to achieve the gas saving in batch minting. And technical details can be found in our published slide paper, but I want to emphasize that ERC 1155 Delta is the only implementation that satisfies the trilemma simultaneously. Now let's take a closer look at the performance. And so the methodology on how we do the benchmark is again in the light paper, and you can also find the script on the our GitHub repo to just reproduce it yourself. So we can see the gas usage of minting multiple tokens are essentially very similar for the 3 implementation. The small change comes from the additional events it needs to emit it. Among them, the ERC 1155 Delta is the cheapest. And for minting like 5 tokens, it saves about it is about 40% cheaper. And as for the transfer, we can see the token in the later part of a minting batch uses more gas for ERC 721A, but ERC 1155 Delta, for it is always the same. In addition, Delta also offers a significant amount of gas saving compared to other implementation. And burning is the part where the ERC 1155 Delta truly shines. And for burning 5 tokens at once, ERC 1155 Delta saves almost like 90% of the gas usage. This makes it an ideal choice for applications that require token burning. For example, RTFKT's forging token or time such as Rocket Factory, both are 2 examples that just requires token burning. And in addition, if all the tokens are burned, there will be additional gas savings to even lower the gas usage. So in summary, ERC 1155 Delta is the only implementation that scales in minting, transfer, and burning. And also its performance in gas usage just outperforms all the existing solutions. One additional bonus of Delta using ERC 1155 as its interface is batch transfer is enabled by default. No need for risking just approving like a third-party smart contract just in order to transfer multiple tokens at once. So why do we think? So when we designed the ERC 1155 Delta, we have a very similar application interface to the ERC 721A. So developers should be able to pick it up very easily. And yeah. So why do we think this project is important, and how does it add value back to the Ethereum ecosystem? So first is ERC 1155 Delta can not only saves like a user tons of gas fee, even on the blockchain that has lower gas fee, it also adds the value. The Delta uses less storage resource, and thus it has like a less impact on the blockchain, to blockchain validators. This helps the decentralization as it will lower the requirements on the hardware to run the node. And ERC 1155 Delta is fully open source and always free to use. So in Setor Lab, we don't have any financial interest in limiting the usage of it, and thus, like your support will be crucial to the continuous development of these projects. And so currently, ERC 1155 Delta is open source, and we have used it in production with our partners from just Elysian System. So I can actually show you the NFT contract. And so yeah, this is the ERC Elysian's latest like NFT smart contract. It is like a 3D PFP project. All the 3D models are synthesized like on the fly, and when people want to mint this 3D NFT, that requires to have another like a NFT from another collections. They need to burn like 5 tokens to just to assemble it. And so as you can see, ERC 1155 is truly really powerful in burning. So it just saves the user that mints the token by a lot of gas fee. And so it is beta tested, and so this is the contract. I mean, this is it's the contract on the Etherscan, and yeah, you can see it has like been beta tested, hence like more than 10,000 like transfers, and all is without any problem. And so this is our website, and so if you want to learn more information, including like light paper and also like source code, you can go to the our website, like erc1155delta.ctor.xyz, and you can also see the go to GitHub to see our source code and download it from npm if you want to use it in your project. Yeah, let me go back to the slides. Yeah, so the requested the funding will be used on just helping the continuous development of this project. And also, even though this project has been beta tested, but auditing will certainly help the mass adoption of that. And in Q2, we also plan to launch a no-code NFT platform integrated ERC 1155 Delta. So the teams that don't have the smart contract expertise can still benefit from it. And also this is a kind of like a news, like just yeah, like I think it's just right before Christmas, I was invited to speak at the largest NFT conference, NFT.NYC this year. And so yeah, and I hope to share more about these projects there. Yeah, so yeah, I'm pretty confident that our team is a team that can build these projects. So Setor Lab is currently in the AppWorks Accelerator program, and so more importantly, and since Setor Lab has been founded, we have published multiple open source frameworks for NFT smart contracts, and some of them have like hundreds of downloads every week and have been used by like multiple projects that have like thousands of ETH trading volumes on the just on the OpenSea. And so we release these all open source frameworks all for free. And yeah, this is our give back to the NFT communities. Thank you very much for your attention. And yeah, I hope you enjoy this presentation. Thank you.
Thanks a lot. Thanks a lot for the presentation. So I'm just wondering, like, for example, there's already some of the like the NFT aggregator marketplace for example, like Jam or Genie. Basically, they have the features to like pack a couple NFT together and check out for one time, which pretty much save users gas fee. So I'm wondering like if ERC 1155 Delta can be implemented into those aggregator marketplace and even help to users to save more gas fees to achieve more convenience.
Yeah, that's a very good question. So ERC 1155 Delta, it implements the standard ERC 1150 interface. So that means for any like standard marketplace, like OpenSea or Genie, and even for the aggregators, as long as they support ERC 1155, they can. There's no problem of using it. And so these aggregators save case by just having combine multiple transaction, right? But ERC even 55, if you're using that, you save even more because just even they are aggregated, ERC 1155, you still use less gas, and because it requires less operation internally. So yeah, user will still benefit from it. And I think so also the batch transfer is a really nice features. So because even for these aggregator, not all the users want to trust these like aggregator or marketplace contract to transfer multiple tokens at once for them. So they need to first to trust the marketplace, so they need to approve it. But for ERC 1150 Delta, these features are built in, so they don't need to approve like any external contracts to achieve this.
Got it. Cool. That's very cool. Thanks for sharing all this information. It's definitely very impressive.
Thank you.
Yeah. So cool. So I guess that's it for today. Our 5 teams all did a great job. Very impressive presentations. It's super helpful for us to better understand about your project and also your visions. Audience, if you have any questions for any of the presenting teams, please feel free to try out their products, join their community, engage with their teams. And don't forget to vote for the teams that your favorite. The Macy voting round is already launched on DoraHacks. You can find on DoraHacks grant page. And also, if you're a builder, if you are like the project owners, Ethereum Research Grants on DoraHacks is actually a long-term grants that always open for applied, but it's gonna be like a rolling monthly review basis. So the monthly price pool is up to 5,000 USDT, and individual projects can be funded from 300 to $1,000 USDT every month. So yeah, that's it. We in the future will have a series of the events for Ethereum Research Grants, like today's. More cool, very interesting, innovative projects will come and join us to demo their products. So if you don't want to miss those future events, don't forget to follow DoraHacks through our social channels. We will keep you updated there. And cool. Thanks for joining us today again, audience and all our 5 brilliant teams. Hope you guys can all doing great in the future. Happy New Year, and hope you guys can achieve some great milestones in the new year as well. And see you guys soon.
Thanks.
See you. Happy New Year. Yeah.
Happy New Year.